Hi everyone. Welcome to one more interesting session on Build Summit 2022. I'm Naveen, Senior Cloud Architect at Snowflake, and I'm joined by Kiran, who is the head of Snowflake Center of Excellence at LTI, here to present a session on PySpark to Snowpark migration. Over to you, Kiran.
Hey, thanks, Naveen. Hi, this is Kirankumar Earalli, and I am head of COE in LTI. And I do lead the LTI Canvas PolarSled product development team, and I do help customers in their cloud modernization journey, especially on Snowflake. And myself, Snowflake certified professional, and having around 18 years of experience in data space, helping customers move to cloud as fast as they can.
So the agenda of today's session is Spark overview, in which we'll cover what is Snowpark, why migrate, what is the architecture, what is the target workloads, and then it's the migration approach, which covers process involved in migration approach and the tools and resources that are available. Then we move on to the PolarSled, which is the core agenda of the session, where Kiran will be demoing LTI's PolarSled. Let's move on. So with regards to Spark overview, so what is Snowpark? Snowpark is the new developer framework for Snowflake, where developers can develop in their language of their choice and deploy them as is into Snowflake. So even currently, people interact with Snowflake using Python, Scala, and Java, but they use Python connector or Spark connector to do that. So what Snowpark enables them is they can basically develop in Python, deploy the code as stored procedures in Python within Snowflake. So that's the feature of Snowpark. Why we should migrate? So we have categorized the reason for migration in the following sections. One is the complexity, the other one is the usability and cost, various data sources, scalability issues, availability risks, and security. So with regards to complexity, infrastructure is complex to maintain and pipeline is really complex to maintain, and obviously there are various tools available out there which is complex to maintain. Adding all this complexity obviously results in usability issues, and also expert resources are needed to maintain this complex pipeline, so which adds a lot of cost. I'll also touch upon a few points on security. Too many places for setting up credentials. Governance is really complex to maintain between all these tools and pipelines. All this can be avoided if we deploy everything within Snowflake with its all governance features. Target workloads. So, with regards to data engineering, ELT, ETL, data transformation, custom business logic, all these are target workloads. So, basically, for Snowpark, for Python, can handle all the data engineering workloads. With regards to data science, data engineering within data science or feature engineering within data science is a target workload. Model training and model inferences can be achieved using Python libraries that are available with Anaconda integration within Snowpark at the moment. For higher memory instances where you need to train with large data sets, these instances will be available soon and you'll be able to perform that as well within Snowpark. With regards to data application, Snowflake has acquired Streamlit. So you can basically develop a front-end app using Streamlit and perform all the back-end activities using Snowpark or using standard SQLs. So these are our target workloads. So moving on, before getting into the Snowpark architecture, I just wanted to highlight the Spark architecture. So this is a common Spark architecture, right? You set the Spark context. Spark context interacts with the cluster manager. The cluster manager interacts with all the executors based upon the number of executors that you have in the pool, and then all these executors interact with the Snowflake database. Imagine Snowflake database is the storage. So what happens here is data is pulled from Snowflake to executors, and then the tasks are performed. The data is returned. So this is a common Spark architecture when the storage is Snowflake. So how Snowpark architecture is different to Spark architecture? So if you see in Snowpark, we support data frame APIs and also Python functions and objects. So data frame APIs are converted into SQL queries by our Snowpark client API, and then SQL queries are fired to the SQL engine, right? With regards to Python functions or Python objects are serialized and converted into Python bytecode, which is getting stored in a Python secured sandbox. So when a Python store procedure is invoked in the processing engine, The SQL engine is connecting to the Python sandbox, which in turn connects to the Anaconda packages that are all supported within Snowpark. So you don't have to build any NumPy or any big pandas packages along with your code. All you have to do is just import those packages, and basically all those packages are pulled from our Anaconda packages. So moving on, the migration approach. So every process of migration has different steps. So these are specific to Snowpark. So discovery is the first stage, mitigate is the second stage, third stage is the convert, and the fourth stage is the migrate. So in the discovery phase, we analyze the code that needs to be migrated. The main reason for the analysis is how much we can automate the migration, how much manual efforts are needed, how complex are the modules, what are the packages that are involved. All this comes in the discovery phase. In the mitigation phase, you'll have to worry about the things that you cannot automate and then identify the solution for that step. And then basically, this is a cycle. So you do the mitigation phase and then again do the discovery phase and then find out how we can efficiently migrate the code. Next comes the convert stage, where you stage the custom packages, whatever custom logics, business logics that you have built over the years in Python, and then convert all the .py modules into UDFs and store procs, stage all the configuration files, orchestrate the store procs, and then logging, monitoring, and testing, everything comes in the convert phase. Finally, the migrate phase is one of data load, which is moving the data first, and then incremental data pipelines. The second stage is moving the pipelines. So all these are the steps that are involved in the process of Snowpark migration. Kiran and LTI team has developed a tool to do all these steps in a tool, which you'll see in the demo. So I just wanted to touch upon a few of the convert steps. So for example, Spark session context, right? So how it is different to Snowpark. So if in the left side, you see the Spark syntax, in the right side, you see the Snowpark syntax. There are few parameters that are needed just because it is in Snowflake. But apart from that, the syntactically both are more similar. Similarly, the slide represent how you read CSV file, Parquet files, and JSON files. You see all the parameters that are there in the Spark is supported by Snowpark as well. With slides syntax changes here as well. The same with writing files, how they are slightly different to Spark. And we have also captured all this data frame APIs in a mapping document. You can refer to this mapping document in the link, where you can see in the left side, you see the functions in PySpark, then functions in Snowpark, then we have captured function parity. Function parity says if there is no change, basically all these functions work as is in the Snowpark as well. So you don't have to do any changes. So if you see in the function parity, there is a word called rephrase. If you see the Python function or the PySpark function has to be rephrased into Snowpark function. So all this are already catered by automated tool like LTI, but you can always refer to this document and it is publicly available for you guys. So the same with column function. You see there are a lot of functions. There is no change because everything works as is. There are few rephrases that are needed. Few functions are not supported currently, and please refer to this link for the updated version of the document. But because every 2 weeks we have new releases where new functions are being added as well. So migration best practices. So these are a few best practices that we have seen over the past. So assess your current architecture pain points and improve the problem areas early on, because once you have implemented a solution, then it is really huge investment to redo the work. So eliminate any technical debts, simplify the architecture, avoid a lot of IOs that were happening in the traditional architecture, determine the metrics that are needed for a migration, whether it could be performance or cost or a code reduction, and then optimize the performance by leveraging Snowflake's compute as much as possible, which is push down approach, leveraging the Python store procedures and UDFs, and then basically migrate all the storage into Snowflake. With this, I'll hand over the session to Kiran, whose team has developed a wonderful tool called PolarSled, and he's going to give you guys a demo of how to convert a PySpark code into a Snowpark.
Thanks, Naveen. Let me first introduce you to LTI. LTI is a global consulting company spread across 33 countries, and we are an elite partner of Snowflake. And last year, we have won a Innovation Partner of the Year award based on our LTI Canvas PolarSled product. And this year, we have won Global Delivery Platform Partner of the Year award. And few stats around LTI. And we run Snowflake as a separate SBU, so around 600 plus associates are working on Snowflake, and we have products and accelerators around Snowflake, which are Snowflake Ready, Canvas, PolarSled, and Phosphor. I just want to highlight one thing here. We have the highest number of Snowflake Advanced Architect certifications across any GSI across the globe. So let me introduce you to LTI Canvas PolarSled. So LTI Canvas PolarSled is not just a one product, it's a suite of tools, I would say. We have gone ahead with a philosophy of Unix here, where each tool does a specific job at its best, and then collectively they solve the bigger problem here. So Canvas PolarSled we have categorized into four pillars: strategize, migrate, govern, and mesh. So let's go to strategize. The first part of strategize is the pre-planning activity of any migration. So we have to understand the current system, how complex is it, or are there any challenges in migrating? Are there any challenges with respect to automation of migrating to Snowflake? So all those things are handled in strategize. So here we have four tools. Today we are going to see two of them, Smart Analyzer and Dependency Analyzer. So Smart Analyzer, what it does is it does the landscape analysis of the existing system, understands the complexity of the current system, and then it highlights the risk associated with automation and what needs to be taken care beforehand before you start your migration journey. Then the dependency analyzer helps you to understand the dependency between the objects, in this case the PySpark scripts, how they are related, how each other functions are being utilized under the other one. That information is really critical for migrating to Snowflake when we are getting it into Python store procedures. Domain Analyzer and Change Monitor are two other different tools which are not useful for Spark to Snowpark migration, but they are helpful in iterative migration, gives the clusters, automated clustering of the objects, and Change Monitor tracks what objects have been migrated to Snowflake and what objects are not yet migrated to Snowflake. Those help in other systems like say SAP HANA, Teradata, Oracle, or any of the other systems, but not with Spark. Then coming to PolarSled Migrate, in PolarSled Migrate is the heavy duty, I would say what the most of the work is done in the PolarSled Migrate, where you convert automated conversion of the current code to Snowflake compatible code happens in this area. So table shift and view shift are the tools which are not used for Spark migration, but they are used for other legacy applications. So Cloud Convert helps in migrating PySpark code to Snowpark code with 60 to 70% of automation. And then once you have migrated the code, then you need something to migrate your historical data, so that we have Cloud Upload, which helps in migrating historical data to Snowflake. Once the data is migrated, finally we have to reconcile the data between the current system and the Snowflake system. So which is our Smart Validate, which helps in reconciling your data from your current system to Snowflake. So now that we have done the pre-planning activity, now we have done the migration of the code, the data, historical data, and reconcile the data. Now we have to start governing your Snowflake system from day one. Snowflake is not only new, it is different. So you have to start governing the system from day one. Again, we have six tools around here. One is around cost, which gives you 360-degree view of your Snowflake account. And the health check, we have come up with a well-architected framework for Snowflake with 100 plus checkpoints, which our Snowflake Health Index helps by evaluating your current Snowflake system, how it is happening. And then the observability platform, which does the threat detection of the your Snowflake platform. Then monitoring, which is a proactive monitoring, kind of a daily newsletter you get with the customized parameters which you want to track on a daily basis in your email box. Then alerting is our Sentry tool, which helps you to there are pre-built alerts and you can customize your own alerts when you want to get an alert. The Sentry helps there, and onboarding, which helps in onboarding your users and your applications in one portal. So that's about the govern. So once you have started governing, you want to get to the next level of your architecture, which is your data mesh. In data mesh, what we have done is we have created multiple tools, again self-service infrastructure provisioning with a Terraform as the background, which can track all the entire life cycle of the journey of each object. Then the marketplace, which is well above and beyond any data catalog, and a data ops tool using dbt. We have built a end-to-end lineage which shows how exactly a data mesh need to be implemented on Snowflake. So moving on, how does Spark to Snowpark journey looks like? So Naveen already explained the kind of workloads we have categorized. Spark workloads are either data ingestion jobs, where ingestion framework has been written, metadata driven framework, which does the data ingestion to any of the systems through Spark, or the most of the jobs are data engineering jobs in Spark and the data science job. So data engineering jobs are the ideal case for migrating to Snowpark, where we are taking the data engineering jobs, we are converting them to Python store procedure with 60 to 70% automation, and then the cloud upload for migrating the historical data, smart validate for reconciling the data across your Hive, Impala, or Delta tables. Then finally, the governance suite of tools. Then for the data science workloads, we have feature engineering as the area where we are targeting for Snowpark migration. So those are again converted to Python store procedure, and the rest of the journey remains same as data engineering jobs. So this is a high level overview of our journey. So this is the landing page of LTI Canvas PolarSled. So we have connections. So mainly we need three types of connections. One is to for Snowflake, another one is for the cloud object store, and a source, which here I'm taking a Databricks connection here. So any new connection can be created from here with a different connection types. And moving on, that's and a strategize pillar. This is the first pillar of Canvas PolarSled. So in strategize, we have smart analyzer as the first tool. So which does the landscape analysis. You can give a Git repository here, or if you already have the code base on your system, you can upload that using a browse button here. Once you upload and say analyze, the entire code will be analyzed and it'll throw out and report something very similar to this. Now I have already analyzed my code base. If you see here, there are multiple folders in my code base, and each folder is shown as a separate repo here. And then it also shows you the complexity overview of each and every script here, how many scripts are simple, how many are complex, or how many are medium. If you see here, it has analyzed 7,000 odd lines of code already, and one out of 125 scripts, and two repositories of Git. So not only gives you the analysis or the complexity of the current system, it also highlights the risk associated with automation. So if you see here, there are 18 risks associated with automation for Git scripts and around 16 for Spark Git scripts. Now, what are these risks? So there are functions with no Snowpark equivalent. Then there are methods which are not applicable, like a repartition or a coalesce kind of things. And there are Cartesian joins. Cartesian joins maybe just a performance issue on a current system, but it might be a cost issue on the Snowflake as well. So those are highlighted here where a manual intervention is required. So we just don't stop at the summary level of the risk associated with the migration. We come down to each and every script and what kind of risk is associated. There is an RDD which is not directly supported, which has to be rewritten. There is a coalesce method. There is a repartitioning used for each method not supported. So all this at each script level, how many occurrences of each risk is there is highlighted here, which can be downloaded as well. And the entire for across the repositories, the inventory list is shown here. So that's about the strategize part, the smart analyzer part here. Let's go back to the next tool, which is dependency analyzer. So going into the dependency analyzer, this is again very crucial for migrating to Snowflake. Again, you select which is the Git repository you have already analyzed and go ahead and analyze it. It gets you to the dependency analyzer, which something looks like here. So basically, what is happening here is each PySpark script is dependent on another script wherever the functions have been interlinked or they have been used. So we have to analyze that beforehand, because when we are migrating to Snowflake Python store procedures, we have to handle appropriately. We cannot link each store procedure with the other one. So either the linkages have to be independently converted to new store procedures, or they have to be embedded into the same store procedure, those functions, right? So this dependency analyzer is very critical for this migration, this analysis. Now, once we have done this smart analyzer, the landscape analysis, the dependency analyzer, now we can move on to the migrate part. The actual migrate has again three tools here: object convert, cloud upload, and smart validate. Let's get into the object convert. So we select the Snowflake connection because I want to create this store procedures on Snowflake, and what type of objects I'm converting, and I'm going to select a repository which I want to do the conversion. Now I have a sample of few scripts to convert here. I can either do the just the conversion part here, or I can convert and create these store procedures on Snowflake. Let me go ahead and convert and execute. In the meantime, this conversion is happening. Let me go and show you an example of a conversion here. On the left hand side, if you see, there's a PySpark code here, and on the right hand side, you can see the converted Python store procedure. So now if you look at this, there are import statements. Again, there are very few import statements on PySpark, but when it comes to Python store procedure, you have multiple import statements, because in PySpark you can import the packages at any point of time, but in Python store procedure, everything has to be imported beforehand, not in between the code, right? So those are all consolidated, and certain things like say SQL expression is not used in the PySpark, but it has to be used because of a particular function being used in the code. So those analysis is automatically done by our tool, and automatically those imports are handled. Once those imports are handled, then if you come down, if you look at the struct type, which we are creating a schema for a particular reason, those are created. Again, the data type changes happen as required to make it compatible with Snowflake. Then if you look at the data where PySpark code is writing it to a CSV file, versus the PySpark code has to be written to a stage in Snowpark. You don't have a way to write it as a CSV to a particular cloud storage or a directory, right? It has to be a stage. So those things are automatically handled. And when you come down a little bit more, like there are things like, say, if you look at this line number 53 on the left hand side, .fname contains a cruise, that has to be converted to something similar to the line number 34 here. So these all changes, the nuances of PySpark to Snowpark are automatically handled with 60 to 70% of automation. And if you come the finally, the way the Spark connector code writes it to a table is something like this. But whereas when it comes to Snowpark, we change the entire stuff and write it to a table with a simpler notation, right? So all these nuances are automatically handled in PolarSled with 62 to 70% of automation. So let's go back to the screen. So if you see here, all the 10 scripts have, which I had selected are converted, and you can see that the status here, all the scripts are converted now. So basically we have done the planning, we have migrated the code now. Now the time for migrating the historical data. So which is our cloud upload. So we'll go to the cloud upload, we'll migrate some data here, sample data. Let me show you the Snowflake screen here. I have created a customer table, and in my customer table, let me show you, there is no data here. Let me upload some data. So again, I need to select a cloud provider, a stage area where I am going to put my files, and a file type, what kind of file I'm going to use, and then I'm going to select a CSV file and upload this. So this is not a simple upload tool, I would say. We can use internal stage or an external stage. You can use a client-side encryption when it is required, and we are able to deliver around 2 to 3 terabytes of data upload with using this tool. So if you see here now, 2000 records have been uploaded to Snowflake. Let's go and check out the same in the Snowflake now. Okay, so all the 2K records have been on Snowflake. Now we have done the planning, we have migrated the code, we have migrated the historical data. Now comes the final part of reconciling the data, what we have migrated with our Smart Validate tool. So let's do the data validation for that. So we'll select the Snowflake connection where we want to do the data validation, and for against what, and then coming to the, I have created this into a Spark demo schema and a customer table. I have to select the required parameters of the customer table. Then do I need to validate all the columns or a set of specific columns? And if there are any PIA columns which I don't want to be available in my report, I can select them, and those will not appear on the report. Now this Smart Validate has 3 levels of validation. One is at the sanity check, the count checks, count all, the count null, empties, and other things. And then the statistical checks like min, max, average. Finally, the SHA1 hash validation, which is concatenating all the columns and comparing that with the hash value from the Snowflake. So even if there is a slightest change in any of the records, it gets caught in the SHA1 hash value validation. In the meantime, this is happening. Let me show you a sample smart validate report, which looks like something like this PDF, which has a table name on the source side, table name on the Snowflake side, and at what time, start time the job was started, when it ended, and what are the columns we have selected, and what operations we have selected, and how much time it has taken, right? All these details are captured, and an overview report against count, min, max, all the three levels, and SHA1 if all the matching records are shown. Then coming to the detailed report, again at each column level, what action is taken, what is the column name on the PySpark side, and what is the column name on Snowflake, what is the result on both sides, and if they are matching or not matching, again it's color coded already. If they are not matching, it shows in red. And coming to the mismatch report, if there are any mismatches for SHA1 value, those are highlighted here. So this becomes like a test evidence for the any migration project. So now moving on to the tool. Now, if you see here, my validation has already happened now. So all looks green, all 100% matching. So that's about Smart Validate. Just to summarize, we have done the pre-migration activity with the Smart Analyzer and Dependency Analyzer, moving to Code Convert, then finally migrating the data and reconciling the data. And coming back to just a summary view, now, LTI Canvas PolarSled. So if you see here, the analyzer part gave us something like months to days of ROI, which is much faster than manually analyzing each and every code. Then at the same time, today we have analyzed around 7,000 plus lines of code and highlighted the automation risks there. Then the code convert, we are around 60 to 70% of automation we provide. But today we have converted on 400 lines of code with 100% accuracy, and we have reduced the data migration and data reconciliation testing efforts using our data migration tool and the Smart Validate. Today we have migrated in this demo 2000 records in a minute, and 2000 records have been basically validated, reconciled against the source. So governance part, which will give you a 360-degree view of your Snowflake platform against your cost, against your performance, observability, all the well-architected framework pillars, and it helps you in optimizing your Snowflake cost and doing more and more workloads on Snowflake. So that's the LTI Canvas PolarSled for you today. Thanks everyone for watching this session. Over to you, Naveen.
Thanks, Kiran, for the detailed demo. Thanks everyone again for watching this video. If you really like this video, give a like and subscribe to our YouTube channel for more videos. For developer related details, follow us on developers.snowflake.com. For engaging with us, follow us at community.snowflake.com. Thank you.
Almost 10,000 miles away from Africa lies an area known as the Silicon Valley. Known for its Patagonia-wearing inhabitants, indigenous scooters, wild robots, and unaffordable housing. Here, we find a lone python that has traveled all its way in search of colder climates, better opportunity, and stock options. The python can grow to be over 30 feet in length and can concatenate string literals together. These non-venomous predators have different diets depending on their size, where most prefer rodents, lizards, and small birds. The one you see here prefers data. Where is this python's journey taking us, you may wonder? Well, to Snowflake, of course. It's in search of their Snowpark to call home after a long voyage across the world. Python for Snowflake has arrived.